Hi guys, this is Vijay. So today we are going to talk about vPC traffic engineering. Traffic engineering. So in the traffic engineering, we are going to talk about where to use peer gateway, okay, and peer switch command, peer gateway, where to use peer switch command, and where to use layer 3 router peer router command. Now, what are the use cases of this in the VPC? So I already have the two devices which are running VPC in the domain 2. So I have nothing configuration in that. So if you see here, this is the switch 3. In the switch 3, I have VPC running. So run VPC. This is the Nexus 9K devices. So I have simply feature uh, VPC. VPC domain 10, we are using the separate 1/5 interface, 1/5 as a layer 3 interface, 1/5 here. Then I'm using 1/1 and 2 here, and 1/1 and 2 here. Okay, as a peer link. So if you see here, this is the port channel number 10, which I'm using because it's stored an interface. So I don't have much configuration running in that. This is the command, this is the configuration I have for the peer link. Okay, and if I show the VPC, so VPC, so my VPC is up and alive. And I have this much VLAN 10, 17, 20, 30 between the switch 3 and switch 4. If I go here, so VPC, so same, both the switches has the same configuration for the PLA. So both VPC is up and running fine. If you see here, so MAC address table. So if you notice here is, if I say so VPC role, so VPC, okay. So if you notice here, in the MAC address table, you will see that the switch local MAC address is switch local MAC address. If I say system MAC address, yeah, this is the switch local MAC address. If you see here in the switch local MAC address, you will see the G tag in there, right? But if you see here in the switch 3, and this is the peer MAC address 5003. But if you see here, 5003 is not visible. Just give me a second. So VLAN, if I say yes, VLAN should be there between them. Okay. So these are the VLAN which are available here. So VLAN. Okay, these are the VLAN which are available here, and same thing here. Okay, there are some extra ports in the switch 4, which is going towards this and this. Okay, so do not bother about this. We will focus on the switches. If I say so VPC, so MAC address table. Here, if I go so MAC address table, look here. If I say so VPC role, this is the primary switch. So switch 3 is my primary switch here. I have this is the primary switch, and this is secondary switch. Okay, and if you say here in the MAC address, the primary switch MAC address is 5003. This is the local MAC address. In the local MAC address, you can see that G tag is here. G tag is here. And if you see in the 5004, only star entry is there, saying that this entry is a primary entry, right? For here. So suppose, for example, you have the load balancer. Okay. And by default, what happens is in each VPC switches, they maintain the three types of MAC address. One is a local MAC address as a primary entry, and virtual MAC address of the your VPC. Which one is a virtual MAC address? This one is the virtual MAC address. Okay, system MAC address we call that. Here we call that 5003 MAC address and 0023 MAC address. Here, this switch will maintain 5004 MAC address and 0023 MAC address. Though you will see that MAC address, but you will see here G tag here. G tag means if any host, suppose there is a one switch connected, right? Switch connected, and it is connected like this with the port channel. If this switch is trying to reach to this router, okay? So if this switch communicate to this one, okay, and it use that 5003 MAC address, not the virtual MAC address, okay, and it reached to here, and if we return back to here and with the 5003 MAC address, this switch will say that your 5003 MAC address is not the gateway MAC address. You have to go to the switch number 3, right? In this case, there is a load prevention mechanism coming in the picture. Switch say that if any MAC address or any traffic coming over the vPC PL link from secondary device, I will drop that traffic. The reason is because same entry is learning from here, same entry if learn from here, this loop will be created in the infrastructure, right? So, and second use case is if we have the source net running here, source net. Okay, source net usually use that symmetric traffic, right? If traffic is coming from here and going here, and if somehow anything hasn't happened for the port in the port channeling, traffic goes here, traffic will be always from. The reason is the switch 4 doesn't have the 5003 as a primary gateway entry, and switch 3 doesn't have the 5004 as a 5004, 5003. So in the 5000, if you just check the switch 3, it has 5004 not as a gateway entry. Gateway means if any traffic coming for 5004 to me, I will not send this particular MAC address traffic over the peer link. It will say that I am going to reply on behalf of this switch. It means it will do the proxy for the on behalf of switch 4. Same thing for the switch here, and this will be use cases when you will say that. So this so MAC address table dynamic. Okay, MAC address table. So if you see here 5000, this MAC address is coming, which is okay. If I go to here 1515. Okay, anyway, so 5003, if I say so, vPC role. Look here. Now, if I enable the peer gateway one, the second option is the source net. If you have the load, but in the load balancer connected and you have source net, and with the source net, you have sticky session enabled. In the sticky session, usually we saying that wherever traffic is coming, same traffic path, usually that session follow that to avoid any kind of asymmetric traffic happening in the between switch 3 and 4. So if I enable, if you see here, there will be entry will be changed here. Okay, so if I go to the primary switch, if I say vPC domain to peer gateway, okay. Now if I say so, MAC address here. If I say so, MAC address table, just give me a second. If I go same thing I do here, vPC domain to peer gateway. And if I say so, clear MAC address table. Dynamic or static, you can say clear MAC address table. Dynamic. Now if I say so, MAC address table. Look here. If I go here, so MAC address. What is showing that? Switch 3 is showing that I have this 5004 as a gateway. Okay, as a gateway here, saying that 5003 as well as a 5004. It means whether traffic, if traffic goes from here, whether traffic from coming for this switch and going through the switch 3, or whether switch 3 traffic coming to switch 4 and going to up. I won't be sending over the peer link to avoid any kind of asymmetric traffic for the load balancing. Okay, this is the use cases of the peer gateway. So I think there is a cosmetic bug here. in the switch 4, it should show that 5003 inches should be coming here over this one. So might be cosmetic, but this is a virtual environment. Okay, 5004 multiple times. So it should be showing that 5003, 5004. Okay, but yeah, I hope you got that point. In the 5 here, you have gateway entry as well as a gateway. Okay, here gateway entry, there should be the 5003 rather than 5004. Okay, now let's come to the second option. Second option comes to the peer switch command. The peer switch command use case is suppose you have the uh, bunch of access switches. Okay, bunch of layer 2 environment. Layer 2 environment. Usually what happens when you have 2 or 3 layer architecture, you keep that spanning tree STP root on the distribution layer switches or core layer switches, wherever you have the gateway. Okay, in this case, I have these access layer switches, and these access layer switches are connecting as a layer 2 trunk. Okay, and for that STP, you do not want to set up STP root, or you do not want to do any real action for STP in the downstream devices. So as per the best practice, STP root should be always your switches where you have the gateway. So in this case, if you have this as a switch, what I will say here is this both the switches. By default, if you say here, what is the gateway here? Okay, if I say so spanning tree. Okay, this switch say that this is a root switch. Switch 3 is my root switch for VLAN 1. If I go to the switch 4, so spanning tree, switch 4 will say that I am not the root switch, but I know that where is the root switch. Okay, between the switches, what is happening here is this is as a claiming as a STP primary, right? Before the peer gateway. This is STP secondary or back. And it is happening over the peer. So what I want to say here is I want to say that keep this as a root as well as this as a root. So if in case any kind of failure happen in environment, there shouldn't be any re-election process happen in the environment. Okay, to avoid any kind of such a TC and BPDU flooding in the environment, I would say that both the switches will act as a root switch. So in host perspective, since this is the BPC, BPC should not have the two different roles. This is the physical connection. This is how logical connection happens after BPC, right? When BPC logical connection is like this, why we are going to have the two different primary and secondary STP system, right? I would say that both the switches will act as a single route. With the traffic coming from here, with the traffic coming from here, it doesn't matter. Traffic won't have any kind of impact. The moment if I say here, what I have to do here is, I will say that exit spanning tree. I will say for VLAN 1, this is the per VLAN spanning tree, RSTP, you have to do it. If it is MSTP, you have to do it instance basis. Spanning tree VLAN 1, priority 819, lowest priority will be always be here. Oh, sorry, highest priority. So I will say that spanning tree VLAN 1, priority 819. If I say so, spanning tree, system will be for now is the same. Switch 3 is still a root switch with the priority of this one. Okay, switch 4 will be still secondary switch. So spanning tree. Saying that this is still secondary switch, even though we have changed the priority. Now, to make that both the control plane or in a single kind of plane, I have to enable the peer switch command. The moment you will enable the peer switch command, both the switches will sync the root switch control plane messaging, and they will claim that I am the root switch and I am the root switch. If I go to the VPC domain, okay, and if I go to the use cases of this VPC peer switch command, so there are multiple use cases for it. Okay, so let me first enable, then list this for the peer switch. That's it. The moment you will see that, this will say that switch configuration is enabled, and this will make sure that bridge priority as per the recommended options. So if you are enabling the peer switch command, so both the switches should have the same priority. Okay, for the VLAN which you want to make as a single route. So if I say so spanning tree, previously what switch was saying that switch 2, switch 4 was saying that switch 3 is a primary, right? And switch 3 was saying that this is the root. Now both the switches should act as a primary. If you say that this is saying that this is the root switch, self declaring that this is the root switch. If I go to the so spanning tree, this is saying that this is the root switch. Previously, this was saying that this is the root switch, right? Over the port channel 10. Now, if you see this is saying that this is the root switch, it means after enabling the peer switch command, both the switches are acting as a root switch. Okay. So peer switch usually work. I think it started working after the 5.0 version. Okay, and this is the feature to simplify that spanning tree configuration. For the VLAN on the both peer with the same spanning tree priority. And peer switch also eliminate the need of the map need to map the spanning tree protocol route as per the primary route to the vPC primary peer devices. Okay, the main advantage for vPC peer switch is to improve the I would say that improvement in the term of convergence time during the vPC primary and secondary device failover recovery. Without vPC peer switch feature, the vPC primary uh, vPC primary switch failure and recovery usually creates around 3 seconds of traffic disruption for south to north traffic. Okay, without a peer switch, traffic disruption is lower to the sub-seconds with the peer switch. Okay, so usually what happens is uh, if any kind of failure will happen in the VPC, and usually it takes around 3 seconds for traffic disruption for north south. Okay, meanwhile this becomes the root switch. So if you have the both root switches, if in case primary fails, convergence will be not happening for specific VLAN. So you can we suggest that we should not be configuring that a peer switch for all the VLANs. However, the VLAN which are more critical in your environment should be configuring that as a peer switch command. Okay. Now let's talk about layer 3 stuff. In the layer 3 stuff, if you want to configure the OSPF. Okay, you want to configure the OSPF now. I have here, usually what happens is PPC has the virtual MAC address concept. So if I go here, this is the router. Okay, so it's not recommended to have the OSPF running between the switches without layer 3 link. It's always recommended to have that if you want to configure the layer 3 between the primary and secondary, you should have the layer 3 link between them. Okay, layer 3 link for OSPF peering. The reason is the BPC failover concept. If primary link fail, or if primary BPC fails and peer link and peer keep live link are up, in this case, SBI and BPC member ports usually goes for downstate. So to avoid this kind of behavior, to avoid this kind of impact in the layer 3 environment, it's not recommended to have the VPC over the PL. So what I have here scenario is I have two switches. This is the VLAN 30 I have. This is a VLAN 30 I have. And here is the VLAN 30 port channel. This is a router I have. Now I want to create the OSPF between. OSPF between. By default, what happened is this switch has two MAC address, right? Local MAC address and system MAC address. Local MAC address and system MAC address. So, and this is the port channel. This is a specific scenario. This is the scenario I have. If PPC form OSPF you configure between these devices, So what usually happen is, just give me a second. What usually happen, if this you configure the OSPF, both the side, okay? Usually this switch configured as a V, what system MAC address. If you form the neighborship here, okay, and by mistake, and this is not the by mistake, this is the LACP hashing port channel hashing mechanism. If the neighborship hello packet send across to this one again, if suppose hello message is happening here and here, and by default due to the LACP hashing mechanism, this time or any time you send that your hello message to here, this switch, because this router perspective, you have the port channel configuration with the vPC, right? vPC member port. The moment this switch receives that this switch MAC address, it will try to send to the over the peer link. And the moment you peer link that the OSP traffic sent over the peer link, it will decrease the TTL value. TTL value. And for the OSPF, for direct neighborship configuration, you have the maximum TTL value 1. Maximum TTL value is 1. So it means if you want to form the neighborship, your TTL should not be decreased in between, right? To avoid that kind of mechanism, what we are going to enable is layer 3 peer-router. It means whether is hello packet coming from here or here or from here, we are going to say these switches, if any OSPF packet or layer 3 routing packet comes, do not decrease the TTL value, whether it's for BGP, whether it's for the OSPF. Okay, the moment you will say that, okay, I'm not going to decrease the TTL, both the switches will start forming the neighborship. Okay, that's one of the use cases here. So let me configure this. Okay, so just give me, not all the devices support that. This is the support. This particular feature supports in a specific versions of the Nexus. So let me show that I here. So if I go to the SO VPC, in the SO VPC, you will see that I have enabled the peer gateway. Okay, and if you say that the layer 3 peer router is disabled by default, this is the feature which we have to enable. Okay, we have to enable that. So what are the use cases we are going to have? Okay, so let me show that some use cases. So if I go to this switch, okay, so what I will do here is in between this switch, I have port channel 30 as a layer 3 port channel. Okay, you can be layer 2 also, it's up to you. I will create one SBI here, port 30, and I will create as an access port, okay, for the layer 3 configuration. The single VLAN, I will allow that. So I will go to the switch 3, I will say that interface Ethernet 1/6, I will say that switch port node access, switch port access VLAN 30. Okay, this is the port I have, which is going port number 6. Okay, then I will say that a channel group 30 mode active. No shut. Okay, interface port channel 30, switch port access VLAN 30, vPC 30. No shut. Okay, then same thing, I will go to the switch 4, and the switch 4 already have the configuration show run. So run interface. If it's check here, port channel number 6 is already configured, and the port channel 6, 30 is already configured with the vPC. Okay, now if I go to this vPC, this vPC port should be up and running. Port channel 30 is down, so let me bring this up. I will say that interface port channel 30, no shut, interface Ethernet 1/6, no shut, Same thing, I will go for the switch 4 and do that. Interface port channel 30. No shut. Interface Ethernet 1/6. No shut. Then same thing I will do for this switch. Okay, in this switch I have created the layer 3 port channel. So if I go to this one and if I run so run in the so run command, you will see that I have a layer 3 port channel 30, and it has the IP address 50.50.1.1.3. So what I will do here is I have switch 3. In the switch 3, I will get that 50.1.1.1/24. Okay, then I have a switch 4. Here I have 50.1.1.4, for example, and I have router or host switch. Okay, where I will configure the 50.1.1.3, I think. Yeah, 24. And we will try to form the OSPF. Area 0. Okay, we call that OSPF area 0. And let's see what happens. And what is configuration here? So let me show that. This is here. This is here. Here I have access VLAN 30. Access VLAN 30. Then I have L3 port channel. Okay, where we have allocated that. So let's go and check that with the port is up. If I go to this router which I have, so CDP neighbor. Okay, so Ether channel summary. In Ether channel summary, both the ports are up, right? Both the ports are up. If I go to the so vPC, fine. This one, and if I go so vPC, this is fine for the interface. This one. If I go to the SBI creation, so first thing is feature interface VLAN. Okay, if on the switch 4, so interface VLAN 30 is already created for me. If I go here, if you see here, this is the interface IP address, and I have enabled the OSPF area 0. If I go to the switch 4, switch 3, I have to create that. I will say that feature interface VLAN 30. Feature interface VLAN 30. I will say that IP address 30.2. 30.1.1. What is that? This IP address? 3, 4, 1. Okay, I will give the 1 as the IP address 1/20. Okay, no IP redirect. I will say that no shit. Okay, then I will ping from these each other. These are we will ping each other. We will try to ping this. Sorry, try to ping from here to here, here to here, and here to here. And let's see whether we have the reachability or not without OSP. Okay. So what I will do here, I will try to ping 50. Is it 50 or 30? I think. Okay, so this is a 50. Sorry, this is my mistake. I have configured 30.30.IP address. Okay, which is wrong, and I might have the issue. Yeah, so this IP address is conflicted with the vPC and it got failed. So I will say no interface VLAN 30. Let me bring my vPC because you cannot use that keep alive for this one. So I will say that interface VLAN 30, no IP redirect, IP address 50.1.1.1/30. No sure. Okay, then I will say ping 50.1.1.3 is reachable, right? 50.1.1.4 is reachable. It's fine, right? It means from this switch, we are able to reach everywhere. Now, I will configure the OSPF. I already have the OSPF configuration in the switch 4. So run OSPF. If I say I have router OSPF, I enable the OSPF for VLAN 30. Same thing I will do here. So router OSPF1, sorry, feature OSPF, router OSPF1. Then I will say interface VLAN 30. I will say OSPF IP router OSPF1 area 0. Notion. Okay. This is what I've configured. In the host switch, which is this router, I already have the OSPF configuration. I can show that. So if you see here, show run. So this on this particular IP address, I already have the OSPF running. At least. So if you see here, yeah, look here. This is the OSPF running for me. Okay, forget about this, ignore that. So now if you see here, the OSPF neighborship should be forming between the switches, right? It should form between here to here and here to here and here to here. It means each switches should have the two neighbors. Okay, and let's see how many neighbors each switches got. When I go to switch 3, switch 4, sorry. If I say so IP OSPF neighbor, it got two neighborship, but one neighborship is stuck in init state. Which one is this? This one is for the router, right? Now, switch 3, if I say so IP OSPF neighbor, one is stuck in a stuck state. Why this neighborship is not forming? We are able to ping the IP address, right? But if you see that, the only the OSPF neighborship is forming between the 3 and 4. Okay, between here to here and here to here is not formed. The reason is hello packet is coming here as a multicast and sometime going from here, sometime going from here, and due to the TTL value between the switch 3 and 4 traffic, the OSPF is unable to form the neighborship. Okay, if you see here, if I debug this OSPF, and let's see what is going on. I will say the debug. How you can run the internalizer also, it's up to you. Debug IP OSPF. Then I will say that adjacency. And what is going on? Okay. And if you see here, this is saying the hello, but if you capture the through the PCAP, you will see that issue with the TTL receive. Okay. Mainly this kind of issue you will get here. And debug all. Now, if I remove the TTL barrier function between switch 3 and 4, and it should be form the neighborhood, right? It will be keep flapping if I go here. So IP OSPF neighbor. Both are done, right? Now, if I go to the switch 3 and 4, I will say that vPC domain to layer 3 Peer-router. If I go save here, vPC domain to layer 3 Peer-router. If I say so, IP OSPF name, you will see that now immediately it has become the full. From the which state? From the init state, I think, or from its start state. If you go here, it was stuck in start state with the router, right? It should it should be full. Okay. So now if you see that all the connection is now full. This is something in IP OSPF neighbor. So IP OSPF neighbor. You will see that both the OSPF neighborship is fine. Okay, this is It's good for the forming the layer 3 with the vPC. And usually between the vPC currently is using the layer this link. I would say that this. Sorry. Okay, so if you see that two neighborship, one between the switches, one is with the router. Between the switches, we should always keep that uh, all the as a layer 3 interface of the team. That's the best practices we have. This is how you can achieve that OSPF or even for BGP anything with your devices. The second use case can be your this is the switch, okay, and you have the router here, but still you want to form like VLAN 30 here, VLAN 30 here, VLAN 30 here. And we want to form the OSPF or BGP neighborship, right, between them. Fourth, still you have to enable the layer 3 peer routing between the switches, because if traffic is coming here and due to the hashing, traffic is going to here, and if traffic again sent to here because of this MAC address entry, you will have to avoid this kind of feature. This is the one of the use case. A second use case is either you can just connect the physical dedicated link, and do not run the BPC on these interfaces. If you are running the BPC and the port channel, then you have to run this concept. Okay. Okay. Thanks for watching. We'll see you in next video.